So just a reminder, I will talk about the one-to-one concept in functions today, but so I asked you to not worry about that. But domain and range, we did get to that on Friday a little bit. Let's see how that went too. Okay, first thing I'd like to do is quickly review what a function is. So remember, a relation is kind of what this is based on. It's just a set of ordered pairs. Like if we have an x, then we have a y value associated with it. That's just a relation. So kind of very broad. And then a function specifically says each input, so each x produces only one y value. So one input gives one y or one output. Okay? And I had you write kind of a long note there that says start thinking of the word function as some relationship between x and y, where the function takes an x and does something to it to spit out a y. And when you start looking at these, they look pretty familiar, actually, like the pink example there where it says y equals 5x plus 10. All that means is just plug in an x, pick some number, multiply it by 5, and add 10, and then spit that out. That is your result, called our output. And so that is a function. And so we're looking in terms of exactly one output. We had different representations of that, but we couldn't ever have one x value give two y values. That's really what we're looking for. And then I'll come back and review domain and range in a second. So if we look at this first one, the table, hopefully you noted that 2 is on here twice, and it gives two different values. So is this a function? No. Okay, and then this kind of random scattered point plot, we call that, well, there's different names, but probably a scatter plot. Okay, again, note at 1, we're getting one y value up there, which is 2, and 1 down here, which is -4. Is that a function? No. So we see in a graph, I think it's easiest to see if something's a function in a graph. That one is not, because 1 produces 2 outputs. How about number 3? Yeah, nowhere on there is there going to be more than one y value for any given x. So this one is yes. And then number 4 is just a line. How about it? Yeah, definitely. Lines are always functions if it's just a linear function. That's what we call it. All right, quick review now of domain and range. So domain is the set of all input values that the function uses. So x values. And then range is the set of all output or y values that the function produces or creates. As we plug stuff in there, like run numbers through it, what y values does it create? And we wrote off to the side that these are both written in interval notation. So we did a quick review of that on Friday as well. Okay, I want to start with the two graphs on the bottom here first. And we'll go here. What do those arrows tell you about the domain? So remember, domain is the x values. And if you didn't do this, take notes with me on it. Like, use it as an example. What do those arrows on the ends of the lines tell you about where this goes? Yeah, it goes all the way from left to right, doesn't it? Forever and ever. So if we're saying what x values does the function use, well, that is all of them, -infinity to +infinity, all the way. All right, range. This is the function's y values that it's producing or creating. So tell me about it. Well, do you see it starts down here at -4? Now, it's kind of hard to tell what's going on up here on the top left. You know, maybe it circles back or cycles back down. We don't really know. I want you to read this one in just for practice, that it starts at -4 down here. So how do we write that in interval notation for our range? Is it bracket or parenthesis? It's a bracket. Yeah, it definitely goes through 4. It touches 4, if you think about it that way. So this would be bracket -4. And then where does it go? This arm of this function shows that it's going to keep going up. Yeah, so it's going to go up to infinity. So the y values that it spits out are going to be somewhere in the range of -4 to infinity. All right, lines are kind of boring for domain and range. Tell me about the domain of this one. Remember, that's x values. So what x values is this line using? Can you come up here, please? Right there. Yeah, come on. What x values is the domain, or is the function using the line? We're reading left to right. What is it using? Does it stop right here? No, why? Because it has an arrow, right? If there was like a circle on there, and that would tell us to stop. So this is from -infinity to infinity. Does that mean all domains are always that? No, but it is often. How about range? Now we're talking y values that the function is giving us. This means it will keep going down and down forever and ever, and also up forever and ever. So what y values does this make? Yep, also -infinity to infinity. Cool. I think I'll skip domain and range for these two just now because I think I want to get us solid on that before we jump into these ones. And like I said, we'll come back to 1 to 1. Let's go ahead and solve this equation. So first step is to distribute. Do you distribute this 3 over to the 4? No, because why? Right, it's not part of the parentheses. Good job. Okay, so we'll get 6x minus 15 plus 4. And then how about the other side? We have no number, just this random negative sign. All right, I like that. Okay. Now, maybe some of you noticed this before, but certainly now you can take note. Do you guys see how there's a plus 4 on both of these? What does that mean we can do with it? We can combine like terms. If we do that, it's just going to cancel, right? Does everybody see why? Like on this step right here, if I say -4 from one side or the other, it just gets rid of it. So that cleans this up just a bit. And now we have 6x minus 15 equals -x minus 1. Okay, what's a good next step?
Get rid of the -1.
How?
+1.
Okay. Okay, now what? I'm going to bring this over here just to have a little bit more room. What would you do next? So she wants to do this. Is that okay? It is okay, except now we have a 0 on one side, so it's adding a step. So what if we just get rid of the 6x on the left? We just want our x's on one side. Does that work? And we'll have -14 equals -7x. And now what? Divide that -7 off. And we'll get x equals +2. How'd you do? Raise your hand if you got that. X equals 2. And you didn't have to do it like me. Just did you get 2? Okay. So pause for a minute and take note of where your work went off track. And make sure that you know how to fix it. Any questions? Maybe I could do it a different way and help you get back on track. Any of that? Anybody need that question answered? Okay. Guys, we will do linear solving. That's what that was all year. So make sure that you're staying fresh with it. Okay. Let's go talk about this idea of one-to-one real quick. It doesn't add much to our check, but then we'll be able to do most of these problems. I kind of wish I had left room to write this, but oh well. Okay, one-to-one function. Okay, all this is each x or input Am I in your way? Produces, and here's the keyword, a unique output. I'm going to just say Y first. So a unique output, meaning that we're not going to see repeated Y values. Okay? If you want, in parentheses, you could say that no repeated Y values. So let's give two quick examples. First one we'll do is called an exponential function. We're going to learn that maybe like in March, maybe February. It looks like this. Is that one-to-one? Does each x produce a unique y? No, you're right. Yes, it's one-to-one. In other words, like, think about it. If I pick an x, it doesn't look over here like that's true because it looks like it flattens out, but it actually doesn't. So, but anywhere along here, if we pick an x, it's going to produce just one y, one unique y value. Okay, next one we're going to do is called quadratic. We will learn it. That's how we'll end Algebra 1 is studying quadratics. It looks like that when you graph it. It's called a parabola. Is it one-to-one? Does each x produce a unique y value? So let's do, for example, 2 and 2. And do you see how at some point both of those make 4? Okay, so -2 and whoops, I forgot the negative. -2 and +2 both make the value 4. So this is not one-to-one. We have 2 4s from 2 different x values. If we made a table, it's even easier to see. If you see a repeated y value in a table, it's pretty obvious. So I think in this case, graphs might be a little harder. Okay, but I'm going to give you 2 tests, and I want you to use these, at least for graphs. You can use these 2 tests that make this process really easy. You can't do this with tables or equations, but for graphs, you can. Okay. First one, is it a function? Use the vertical line test. And this is so easy, it's nice. You guys will love it. I'm going to underline that. If a vertical, now you have to know which way vertical is. Up and down, right? If a vertical line touches more than once, it is not a function. So do a quick just visual representation of what the heck we're talking about here. Okay, let's say we had this kind of shape. Now, I think you guys are good enough at this point with this concept to say, no, that's not a function. But just draw a vertical line. There's our vertical line. If it touches more than once, it's not a function, right? So not a function. And the reason why, it's just because I'm drawing a vertical line on one x value. If I hit the thing more than once, it's giving two y values, two or more, perhaps. Okay. The other test is it one-to-one? Can anybody think of another line test that we could do? Yeah, awesome. Good job, Jeremiah. So is it one-to-one? This will be the horizontal line test. So I'm going to abbreviate. If a horizontal line touches more than once, it is not one-to-one. And we did one just right up there, but we can put it here just to represent that. So if we have our parabola and we draw some horizontal line through it, touches more than once. So not one-to-one. All right, let you get caught up there. Okay, so these work nice if I give you a graph, but again, if I give you an equation, if I give you a table, you still have to know the concept and be able to see it in those forms as well. If you have a graphing calculator, I guess sometimes if I give you just a function, you could graph it on there, and then, or Desmos, and then you'll see a graph, and then you can do these tests really easy. Do you guys know how to use Desmos? The Desmos graphing calculator? And so you should have a Chromebook. It's just a free website. You just Google Desmos graphing calculator, and then it's ready to go. Oh, I can show you, but let's get everybody caught up here. to go? Are you good? You sure?
I can do that.
Okay, real quick. Is this 1 to 1? We already said it's not a function, but is it 1 to 1? Well, we have unique y values, right? Okay. How about this one? Is it 1 to 1?
Yeah.
Look right there. -2 makes 2, and 1 makes 2. So it is not 1 to 1, is it? Okay. How about this one? Is it 1 to 1? Horizontal line test. Lots of places that one is not 1 to 1, right? And it's again because like if I pick this x, I'm getting like -3, but also that x makes -3. Okay, so not 1 to 1. How about this line?
Yes.
Yeah, if we do the horizontal line test anywhere, it never has more than one y value. So, is that a function? We're just going to run through a bunch of these. Don't try to write them down. Let's just be fast. So don't shout it out, but I'll say, okay, everybody tell me your answer. So is it a function? Is it 1 to 1 or not? So think about your answer, and then I'll say, go ahead. Okay, is it a function? Yes, it's a function. How do we know? Only each x only gives one y. Remember the whole arrow thing? They're only shooting one arrow, right? So one arrow, etc. Is it 1 to 1?
Yes.
These two are both pointing to 17. So that means not 1 to 1. Okay? See if you can do this one. Is this a function? By the way, this is x, y, x, y, x, y, x, y, like they're coordinate pairs. Is it a function? Don't shout it out. Just think real quick. So you're asking, does each x give one y? One y. Yep. We don't see any repeats. Like none of these x's are repeated, right? So that makes this a function. Is it 1 to 1? Yes, function and 1 to 1. Is this one a function? This is like Hawkeye, right? No, 3 is shooting 2 arrows at once. Doesn't he do that? Or Legolas, if you're a Lord of the Rings fan. So not a function. How about a line?
Yes.
Lines are always a function, and they're always 1 to 1. All right, let's do a couple more. Let's do a couple more tables. So first, number 1, is it a function? Yes?
Yes.
Is it 1 to 1? No, not 1 to 1. Okay, table 2, is it a function? Okay. Is it 1 to 1?
Yes.
Awesome. Now notice the problem actually asked for the domain and range there. I kind of want to save that for just another function.
No.
And why not? Right? How about this one? Function 17?
Yes.
Is it 1 to 1? Why is it 1 to 1?
Then one.
Yeah, each y only has one arrow pointing to it. It's unique y's, right? No double y's. All right, how about this one? Function.
Yeah, no. No.
Yep, it's not a function, you're right. Is it 1 to 1?
No.
And that's because down here, 2, -2 and 0 both point to 15. All right. Any questions on those? Okay. So on this, what does an open circle mean? Do you think that means included or not included in your domain or range? Not included. Good. But like over here on this one, a closed circle means included. Okay. Please don't draw these graphs.
Oh.
Just give me the domain and range for each one. I'm going to have to do this like piece by piece. Otherwise, you won't be able to see the numbers. So let's do those two and then check, and then do the next two and then check. So maybe like a minute or two on each one. Okay? So just domain and range. You're not answering if it's a function or not. All right, number one. Remember, domain is left to right. You know what? I want to actually write that on your notes. So go grab your domain notes. Because as we get into reading domains from graphs, well, domains and ranges, it's important that you know which direction to read. So we're looking at X. This is left to right. That's important, not just for now, but also for later on in math. And your range, what do you think it is?
Right to right.
Well, first of all, it's Y values. Bottom to top. Remember, range is Y, so we have to look from the bottom up. Everybody got that? Okay. Oops. That's where we were. So let's do domain. That's left to right. Okay, where does this start? On the left side. It starts at -5. Is that bracket or parenthesis? It has an open circle. So it has to be parenthesis, okay? It can't be -5. That's what open circle means. Okay, then it goes over to what? So if you think about it, we're like using x's, stop. At 4. Can it be 4? Well, is that circle open or closed? Open. So can it be 4? No. Open circle means no, right? 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 Okay. Now let's do range. Okay, we just wrote the range is bottom to top. I'll rewrite it here. Is bottom up. Okay, this is how I describe this. We're scanning, I don't have any values, no values. Right there I hit a circle. And it's on 4. So I'm gonna write 4. Can it be 4? Nope, that's an open circle. Okay, we keep scanning, and it stops at 6. Can it be 6? No, so comma 6. Because both were open circles, we have parentheses on both. So,
Like brackets, like in first quarter, right? Brackets, like open circle.
yeah, closed circle is bracket, open circle is parentheses. Same as our inequalities, okay? All right, let's do this one. Okay, we're scanning left to right. That's the X values used. Scan, nothing. Oh, right here I start to pick up an X value at -1.
Closer.
Can it be -1? Yes, it's got a closed circle, so bracket. Okay, we keep scanning, and I quit getting values at +1. Can it be +1? No, so that is parenthesis. Okay? All right, range. Scan from bottom up. Scanning. I hit a value at -1, but can it be -1? So parenthesis. Okay, keep scanning up to 1. Can it be 1? Yes. All right.
Wait.
I did. Jesus caught me. I put a parenthesis, but it was supposed to be a bracket. Good job. Thank you. All right, do those real quick while I hand out this piece of paper. You're going to have to be fast about it.
Oh man. Thank you.
Thank you.
What's the homework?
This is gonna be 6.
Is there backside?
All right. How'd these go? Is everybody done with those two? Okay. Remember domain on number 3. We're scanning left to right. So scan. We first pick up a value at -3. Can it be -3? No. And then scan to the right. We lose the values at 0. But it can be 0 because of that closed circle. Okay, hold on. Before you pack up, circle number 8. Number 8. 13, 14, 18 to 21. I will put that on Google. Have a good day.
Ready?